The first step in any problem is to decide what's being asked of you and what you're being given. What information do you have in order to solve the problem you're being asked? In this case, we're being asked for what species has 28 electrons. And then we're, of course, given these three species here to choose from. The information that we're being given is essentially the identity of the species and then the charge that the species carries. In this case, since we're being given three choices, and then our answers, when we look at A, B, C, D, and E, could include some mix of those, if I were solving this problem, I would just determine how many electrons each one of these species have, and then from there, go ahead and decide what the correct answer is. So let's do that. How to solve this problem? Let's start with answer choice 1. Zinc is element number 30, which means that there is 30 protons. We also know that this particular species has a charge of +2. What that means is that it's missing 2 electrons, or that there's 2 less electrons than there are protons, which then means that we have 28 electrons. Alright, so there's one answer choice that's correct. Let's consider the others. We're also being asked about nickel. Nickel is element number 28, which means that there are 28 protons. In this case, the element is neutral. It has a charge of 0, which means that the number of electrons is equal to the number of protons, which means that there are 28 electrons. Then we have copper. Copper is element number 29, which means that there are 29 protons. It has a +1 charge, which means that it's missing 1 electron compared to the number of protons. Again, this means that there are 28 electrons. So then when we look at our answer choice, we see that all of these have 28 electrons, and the answer is E. This is a rather interesting result because it shows us that we can have multiple atoms that all have the same number of electrons. We're going to see later on in the semester the impact of this, but I'll mention right now that when you have atoms that have the same number of electrons, we call those isoelectronic, meaning that they have the same electronic configuration. Anyway, let's move on to the next problem. Here we're dealing with a problem that is asking us, again, we're going to diagram the problem to decide what we're being asked for and what we're being given. So we're being asked for the atomic weight for the other isotope of bromine. Something that's interesting here is that we're being told something about one particular isotope of bromine, this bromine number 79, right? And then we're being asked for the only other isotope, which means there's only 2 isotopes, and together they're going to have to add up to the atomic mass that we observe. So how to approach this problem? Well, what it's basically asking you for is to decide what the mass of bromine must be in order to observe the mass that we get on the periodic table. We know that because it's talking about the natural abundance and referencing isotopes. So the first thing we want to do is look at the periodic table and from there determine what the mass of bromine on the periodic table is. That's going to be our average molar mass. That average molar mass, we know from class, is just going to be equal to the fraction of our 2 isotopes. So we'll have the fraction of bromine 79, the one that we know about, times its mass, plus the other isotope. So we're going to have the fraction of bromine, we don't know what it is, and then the mass of that. Then we're being asked for basically what the atomic weight or the mass is of bromine. So let's write down what we know. We know the average molar mass, or the average, I guess in this case, let me cross this out, atomic mass is going to be 79.9 AMUs, atomic mass units. We know the fraction of bromine 79 is given to us is 54.8%. So we're going to have 0.548. That's the fraction that corresponds to 54.8%. Then we have the mass of bromine 79. By definition, bromine 79 has 79 nucleons, that is 79 protons plus 79 neutrons, which means that since each one of those has an atomic mass unit of 1, that we're going to have 79 AMU plus something we have to know about the fraction of bromine that we don't know, but that's basically 1 minus 0.548. And then we have our mass that we don't know. So we can then solve this problem by doing some simple arithmetic. So we're going to have 79.90 AMU. Then when we multiply the first term here, we're going to end up with 43.29 AMU plus 0.452 times our mass that we don't know. Alright, then all we need to do is subtract one from the other, so 79.90 minus 43.29, all divided by 0.452, and that's going to actually give us our answer. The mass, what other isotope of bromine? So, let's go ahead and solve that. The mass of the bromine isotope is going to be equal to 81 atomic mass units. Alright, so now we have an answer at 81 atomic mass units. We see that corresponds to answer D. Let's just stop and think for one moment about whether or not that makes sense. We see that the average molecular mass that we're being given, that we use here, is 79.9, which is larger than the mass of the known isotope that we had, 79. So that must mean that our unknown isotope has to be larger or more massive than 79. It's 81. That makes sense to me. And so D should be the correct answer. It's always worth looking at the answer you get and then thinking about whether that answer makes sense given the information that you have. That's a quick check that you can do while taking an exam or a quiz in order to decide whether the numbers that you've run are giving you an answer that makes sense.